Look up at the night sky, and you'll see mostly empty space, just darkness, broken by a few scattered stars. But that darkness hides an almost incomprehensible scale. Out there are hundreds of billions of galaxies, and each one holds hundreds of billions of stars. If the universe stretches out forever in every direction, every possible line of sight should eventually lock onto a star. Space should not appear empty. Based on that logic, the night sky should be blazing. Every single patch of the sky should glow with the same intensity as the surface of our sun. This contradiction between what math predicts and what our eyes actually see bothered astronomers for centuries. It became known as Olbers' paradox. If the universe is infinite and unchanging, the blackness above us makes absolutely no physical sense. Our fundamental assumptions about reality must be flawed. At first glance, the answer seems obvious. Maybe stars are just too far away, too dim to see. But that explanation fails due to the geometry of space. Looking further away means observing a drastically larger volume. Individual stars get dimmer, but at double the distance, you capture 4 times as many stars. Their combined numbers perfectly cancel out the dimming. Think of it like standing in a dense forest. The trees far away look smaller, but there are so many of them that they eventually block every gap in your line of sight. You see a solid wall of wood. Space should be a solid wall of light. Astronomers then tested another idea. They proposed that vast clouds of interstellar dust act like a shield, absorbing distant starlight. That fails once you factor in heat. If a cloud of dust absorbs starlight over an eternity, it will eventually reach thermal equilibrium and radiate its own light right back at us. That leaves the stars themselves. They don't live forever. They have finite life cycles, which could theoretically leave dark, empty gaps in the cosmos. This assumes the universe is eternal. But if time stretches back infinitely, new stars would continuously form to replace the old ones. Over an eternity, constant star formation would easily fill any dark gaps, saturating the space with light. Every simple physical explanation leads right back to the same result. An infinite universe should be completely overwhelmed by light. Solving the paradox requires moving beyond distance and matter. The true issue lies in our assumptions about the origin and age of the universe. The breakthrough requires a specific rule of physics. Light travels at a staggering speed, but that speed is finite. Because light takes time to cross the void, looking into space is looking back in time. A galaxy a billion light-years away appears exactly as it did a billion years ago. Beyond a certain distance, the light emitted by stars hasn't arrived yet. This reveals that the universe hasn't existed forever. It had a beginning, and there hasn't been enough time for light from the furthest reaches to reach us. This creates a physical limit to reality, an observable horizon. This darkness marks a visual boundary, defining the age of the universe itself. One final complication remains. The light from distant stars that does manage to reach us is altered by the expansion of the universe. As space expands, it stretches the light waves traveling through it. This is redshift. That stretching drains the light's energy, shifting it out of the visible spectrum until it is undetectable to the human eye. This stretched, invisible light remains present in the universe, detectable to astronomers as a faint, uniform microwave radiation hovering just above absolute zero. This is the cosmic microwave background. It is the persistent afterglow of the early, densely packed universe, covering the entire sky. The night sky is actually blazing with evidence. The darkness between the stars proves it had a beginning, that it is constantly stretching, and that it hides an invisible glow right at the edge of time.